In this video, we're going to look at vectors in multiple dimensions, or in two dimensions. So far we have looked at one dimension where we had two vectors that are either pointing in exactly the same direction and we just add them, or they're pointing in opposite directions and then one of them becomes negative, we still add them, or we could say that we subtract their magnitudes in order to figure out the resultant. Now we are going to actually look at what happens if these are at an angle to one another. Right. Now, when we add vectors, we're going to, again, just use tail-to-tip method like we did before. So I can move vectors around in space as long as I do not change their length or their direction. Right? So if I were to first place this vector, and then I bring in the second vector, I'm going to put it at the tip of the last, right? So they'll point in the same direction. And then my resultant would be from where I started here to where I ended up. So it would be something like this. Now, let's say we're actually to add the vectors in a different order. Let's say I put this one first. Okay? And then I come along and I place this one. You know, if I can do a good job at not changing their direction, then if I draw the resultant vector, you should see that they should be the same magnitude, the same direction. Right? So it doesn't matter which order you place vectors, you will always end up with the same resultant vector. Right? So let's go ahead and add a couple of vectors and look at the method to adding vectors if they are at an angle as you see here. Okay? So let's say I have, let me just draw my coordinate system here. Okay? Let's say I walk in this direction 13 meters, and let's say that my angle is 37 degrees. Okay? Then from this position, I walk in this direction, okay, similar to sort of what I did up here. We'll say 5 meters, and let's go ahead and describe that angle as being, I don't know, 25 degrees, okay, below the positive x-axis. Okay. If I were to come in then and draw my resultant, you would see it would go from the tail of the first to the tip of the last. So right here, this would be my resultant vector. Now, I want to be able to both describe its length, but also to describe its direction. So I want to know how long this is and what this angle is. Those are my two questions when I'm adding vectors. Right? So let's go through the steps in order to solve this. First step we've already completed is to use tail to tip. Right? The second step is to use what we learned in the first lesson about components. So I'm going to solve for the x and y components of all of the vectors that I have. Right? So let me just go ahead and draw them in here. We've got this x, and I have this y. And then over here, I've got this x, and I've got this y. Right? So in order to solve for this side, here's my right triangle there. So in order to solve for the x of the first, I'm just going to call it vector 1, x. I would take the cosine of 37 and multiply it by the side, which would be 13. All right, let me grab a calculator here. So cosine, or 37 cosine times 13 gives me 10.38. And if I look, I can see it's to the right, so that's going to be a positive 10.38. And if I wanted to figure out the y, then I would just call it vector 1y and say that that is actually the sine of 37 times 13. So 37 sine 7.82. Right? Now I'm going to figure out the x's and y's of my second vector here, right? So my second vector, if I'm going to do x, vector 2x is equal to, so I'm going to do the cosine of 25 times 5. So the cos 25 cosine gives me 4.5, and again it's to the right, so I'll make it positive. And then over here I'm going to do vector 2y, and this would be the sine of 25 times 5. Right? And I get 2.1. But if we look at my component, I see my component's pointing down, so I'm going to make it a negative 2.1. Okay? Now, if you can see here, this is the resultant. Let me do it with kind of a bigger marker. This is my resultant. So let's draw the components of my resultant. I have this, and I have this. Okay? Hopefully you can visually see that if I were to add this x component here and this x component here, they would actually sum to be this, right? You can see if I go here and here, that's the same as this total side. Whereas if I were to do the y, I would take this one and minus this one, and it would give me this. So the third step is to add all of the x's and y's. And that will actually give me my resultant x and my resultant y. So my vector resultant x is going to be equal to 10.38 plus 4.5, which gives me 14.88. Okay. And then my vector resultant y is going to be 7.82 plus 2.1 and then negative, right? So naturally subtract. So that would be 5.72. That gives me two sides of the right triangle that makes up my resultant vector, right? So then in order to find this length right here, the next thing I'm going to do is use Pythagorean theorem. Right? So vector rx squared plus vector ry squared would actually give me my resultant squared. Okay, so 14.88 squared plus 5.72 squared. And then take the square root of that, and I get 15.94. So my vector resultant is 15.94 meters. Okay. And I'm not done yet. So that gives me the magnitude or the length of my vector. But we also said that we want to know the direction or the angle. So in order to do this, I am going to then use trigonometry. Now I have all of the sides, so I could really use any of them, but I'm going to use tangent. So use trig to find the direction or the angle, right? So you have the opposite, which is my vector resultant y, over my adjacent, which is my vector resultant x, and is opposite over adjacent, so I'm going to do tan to the negative 1, and that would give me theta. So 5.72 all over 14.88, and minus 1 equals 5.72 divided by, and then second tangent, I get 21 degrees. So the full answer to this vector addition or summing of these two vectors that are multiple angles would be that it is 15.94 meters at an angle of 21 degrees. Now, I could also qualify that by saying above the positive x-axis or north of east. But without qualifying it, I assume it was in the right quadrant, which it is. If it was over here, then I would definitely need some more words. Okay? So that is how you add multiple vectors. In the next video, I'm actually going to add 3 vectors, and hopefully you'll get the hang of it at that point, and really should be able to add after that and after some practice as many vectors as I were to throw at you at a time.